Welcome to The Explainer. Today, we're cracking open the original Solana white paper to understand its single biggest innovation, a really fundamental solution to one of blockchain's oldest and thorniest problems. It all kicks off with a question that, let's be honest, has probably frustrated you if you've ever used crypto. Why, in this age of instant everything, can a decentralized network feel so painfully slow? This has been the great speed bottleneck for years.
Think about it like this. In the regular world, with Visa or your bank, there's one source of truth for time, one clock. So ordering transactions is simple, it's fast. But on a blockchain, you've got thousands of computers all over the world, each with its own clock, and they're all slightly different. Getting them all to agree on the exact order of events without a central boss is a huge mess. It's like a traffic jam where nobody agrees on who has the green light.
The white paper really boils it down to this one thing. Public blockchains have always made a, quote, weak assumption about the participants' abilities to keep time. This simple problem, the lack of a shared, trusted clock, is the fundamental challenge that Solana's founder, Anatoly Yakovenko, decided to tackle head-on.
And the paper's answer is an entirely new architecture, built around a pretty radical idea called proof of history. And this isn't just a minor tweak, it's a completely different way of thinking about how time works on a blockchain.
So, what on earth is proof of history, or POH? Well, the paper defines it as a way to, quote, encode trustless passage of time into a ledger. But what does that actually mean? It's not really a consensus mechanism itself, like proof of work or proof of stake. Think of it more like a helper, a cryptographically secure clock that the whole network can just look at and trust, without having to constantly call each other up to ask for the time.
So, here's the million-dollar question. How do you build the clock that everyone can trust, but that nobody actually controls? It sounds kind of impossible, right? But the mechanism they came up with is actually surprisingly elegant.
It works like this. You start with pretty much any random piece of data. You run it through a secure hash function. Think of it like a unique digital fingerprint. It spits out a new, totally unpredictable fingerprint. Then, and this is the magic trick, you take that output and you feed it right back in as the input for the next hash. And you just keep doing that over and over, creating this long interlocking chain.
And here's the crucial bit, right from the white paper. Because it's a cryptographic hash, you absolutely cannot predict the next output. There's no shortcut. You can't cheat, you can't skip ahead. You have to physically compute every single step to know what comes next. And that sequential work, that's your verifiable proof that real, actual time has passed.
This is where the clock gets really useful. You've got this chain of hashes, this constant tick-tock just running along. When a new transaction comes in, its data gets mixed right into that sequence. The very next hash that gets created then acts like a permanent timestamp, basically locking that transaction into the timeline and proving it existed before that exact tick of the clock.
And this is where the system gets really smart. Creating the timeline is slow, is sequential, it has to be, to prove time has passed. But checking that the timeline is correct, oh, that's lightning fast. A validator can take the entire history, chop it up into thousands of little pieces, and use a modern GPU to check all of them in parallel, confirming the whole thing is legit, almost instantly.
Okay, so we have a reliable, trustless clock. But why is that such a big deal? Well, according to the white paper, having this clock as a solid foundation just makes everything else so much simpler and so much faster. The biggest impact is on consensus, the process of getting everyone to agree. Normally, validators are constantly sending messages back and forth trying to figure out what happened when. With proof of history, they don't have to do that anymore. They can just look at the shared timeline. This cuts out all that extra chatter, which lets the network finalize transactions in, as the paper says, sub-second time. It's a game changer.
All right, we've gone through the clever clock making and all the cryptographic magic. So what's the payoff? What's the bottom line? What does all this innovation actually get you?
Well, this is the part of the white paper where they make their most audacious claim. By solving the time problem, they proposed a theoretical speed that was just unheard of back then.
710,000 transactions per second. That's the number. The theoretical maximum they calculated was possible on a standard 1 gigabit network. It's a staggering figure, and it's only possible because the main bottleneck, agreeing on the order of events, is gone.
And just to really put that number into perspective, let's look at the speeds of other blockchains at the time. We are not talking about a small improvement here. This is a monumental, orders of magnitude leap in potential capacity. A completely different ballpark.
So in the end, by focusing on and solving the problem of time, the Solana white paper did way more than just propose a faster blockchain. It actually laid out an entirely new blueprint for how you could build a high-performance, decentralized network from the ground up.
So if you boil it all down, the key insight is actually pretty profound. For years, the hidden bottleneck wasn't just raw speed. It was agreeing on time. Proof of history offers a clever way to solve that, creating a verifiable record that unlocks massive efficiency. Essentially, Solana's big idea was to weave time itself directly into the fabric of the ledger.
And this all brings us to one final, really provocative question. Solana's white paper basically bet the farm on the idea that a clock was the missing piece of the puzzle. So as we look to the future, it makes you ask, is this focus on a verifiable universal passage of time the key that will finally unlock blockchain's potential for a truly mainstream global scale? The final answer? Well, that story is still being written.